Hi guys, welcome back to another day of distance learning for science. We're going to be starting something a little bit new today. So we've been looking at chemistry, atomic science, and today we're going to be moving on to acids and bases. So acids and bases is obviously a part of chemistry, but it's a more specific part we're looking at today. So firstly, we're going to be looking at acids. What is an acid? So you've probably got a general idea, or maybe from TV or video games, what acid is. Pretty bad for you. Don't want to get it on your skin. It might burn you or something. I've probably told you in the lab not to, if it gets in your eyeballs, it's really bad. That's also true. So yeah, acids we generally consider going to be quite harmful. While that's definitely a good rule of thumb to play, there are weak acids out there like your lemon. You can see this lemon here, which while it's definitely acidic, it's not going to be too harmful to you. And then next to it, we've got this one, H2SO4, which is sulfuric acid, which is definitely going to be harmful for you and you should be extremely careful with. So what it says here is acids are a family of substances which all show acidic characteristics or properties. Doesn't really mean much. These properties relate to how the acids react with other chemicals. So it says here acids have a sour taste. You probably know lemons are sour. As far as the other acids we deal with, let's just say you can assume they have a sour taste. Do not try to taste them. They are extremely bad for you, obviously. And they react with metal. Okay, so all acids react with metal. It's interesting. And acids can be found in nature and called organic acids. So this is like the lemon acid. You may know what it's called. Citric acid. So that's organic acid. It happens naturally. Or they can be made in labs and they're called mineral acids, such as sulfuric acid. So here are a few acids that we use in the lab. First one up the top, hydrochloric acid, HCl. This is a formula here. And if you remember this, H, hydrogen, Cl, chlorine. So it's one hydrogen atom and one chlorine atom. Easy mistake to make for some people is they'll look at this one and they'll go, I have an H there. That H is hydrogen, then I have a C for carbon, and then an I for iodine, HCI. That's not what it is, that is an L. So if it was HCI, hydrogen, carbon, iodine, that would be a capital I. Because it's actually an L, this is HCl, hydrochloric acid. Hydrochloric acid is found inside your stomach, really good for breaking down food you're eating, and your stomach's really strong and can actually contain that hydrochloric acid without getting eaten up by it. I will have to say this does not mean you can drink hydrochloric acid because your stomach's got it inside there. That's not how it works. It will definitely burn your esophagus and mouth going down. Sulfuric acid, might get some of that naturally forming around Rotorua, around those sulfur mud ponds. Nitric acid, very important acid for dissolving stuff, extremely strong. And then this one here, ethanoic acid, which is the acid you find in vinegar. So here's my rice wine vinegar today. So this has got this one in it called ethanoic acid. And you may know vinegar is natural product. This is rice wine. It's made from rice. They just get rice, leave it to ferment for a while, leave it to rot for a long time in oxygen with some bacteria, and it starts forming this acid, ethanoic acid, which is vinegar. And in this vinegar, it's going to be about, I don't know, maybe 30% that ethanoic acid and the rest water. And vinegar obviously is a food, you can drink it, It's not going to hurt you. So the common things that acids do is they react with most metals to form hydrogen gas, and hopefully we'll be able to do this when we get back to school. Taste sour like lemons. Yeah, well, don't test it yourself. Frequently feel sticky, and they're usually gases or liquids. These are 4 common acids. Now, those are the properties of acids, but if we want to explain why they're acids from a chemical point of view, we explain it like this. All acids contain hydrogen. If you look at all these acids, hydrogen, 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 hydrogen. When an acid reacts, it gives away its hydrogen ion, which is really just a proton, and the electron remains behind. So here I have an acid. This is an H here, and this one I believe is Cl. This acid we have is hydrochloric acid, HCl, and it's really the simplest acid, just 2 atoms. So what acids do is they give away their hydrogen. This atom, this molecule here, it's an oxygen and 2 hydrogens. This is water. And if I put HCl in water, it's going to give away this hydrogen to the water. And what it forms is this product. And the acid has lost its hydrogen. So the important thing with hydrogens is with acids, is when they're in water, they give away their hydrogen, and it makes this molecule. This was water, H2O. This one we call H3O. Now, if those are acids, bases are the opposite. Bases are a family of chemicals that don't have H pluses present, like these ones. These have H pluses. Instead, they have OH minuses. So when they're put into water, they're going to start producing OH minus ions. Common household bases include floor cleaners, so like anything with ammonia in it. It's got a very distinctive smell. I've got some Handy Andy, which I used to clean the floor. It's got bases in it. Antacid tablets, like those tablets you eat for heartburn, indigestion. So those are some common bases. And if the base, such as maybe this one here, baking soda, if it can dissolve in water, we call it an alkali. So alkali and base are pretty much the same thing, and they're often used interchangeably. But the important thing to remember is that an alkali is just a base that can dissolve in water. So here are 4 bases. Some of them you can see do have OHs on them, and the other ones will actually form OHs when they react with water. But we'll be explaining that later when we're showing the reactions of these bases. So we've got stuff like this, sodium hydroxide, which is it's used for lots of things, but one of them is Drano, like drain cleaner. Pour it down your drains and it dissolves everything in there. Calcium carbonate, which is basically chalk, that very same chalk you write on the board or marble. It's a solid rock. That's a base. Ammonia, the stuff you smell in floor cleaner, and potassium hydroxide, which is a type of fertilizer as well. So here it says for bases, they often are slippery because your skin dissolves a little when you touch them. That doesn't sound great, but stuff like soap is basic. So it's pretty good to clean your hand that way. Taste bitter like baking soda. Once again, don't don't just taste chemicals. But yeah, baking soda probably tastes better. Reacts with oil and greases like soaps and stuff. Yeah, they're generally basic. And that last one, which you may not be able to see, says frequently solids. So stuff like calcium carbonate is a solid. Sodium hydroxide, yeah, these are solids. Ammonia is a liquid, but it's a gas. It's a gas that can be dissolved as a liquid, but a lot of them are solids. So here we go. An acid on the left is a molecule that gives away an hydrogen ion. Here are my hydrogen ions. And a base can contain a hydroxide ion. I've got to contain them. I've got an O and a H, OH. Now, when an acid reacts with a base, what happens is this H reacts with this OH. H plus OH equals water. So when you get an acid and a base and you react together, it is going to get the H from the acid and the OH from the base and produce water. And then we're going to get these two ions left over, Na and Cl, which will then form something called a salt, which you may have heard of before, such as table salt, which is a common one. But there's lots of different other types of salts in chemistry and science, which we'll be looking at. I'm just going to leave it at there today and quit out of this and show you a couple of pages that I'd like you to do in the Scipad. So this is page 28 and page 29. So page 20, zoom in. Page 28 just starts with what is an acid. So yeah, it just starts with what is an acid. Read the stuff at the top and then work through these questions. It's very simple. Where does the word acid come from? Hopefully that's the very first sentence. The word acid comes from the Latin acidus. There you go. Let's see if there are any tricky questions. How 3 acids we often use in the lab. They're included there at the last sentence. The main difference between a concentrated acid and a dilute acid, yeah, that's an important bit. In a concentrated acid, there's a large amount of reactants in the water. In a dilute acid, there's going to be a very small amount of reactants in the water. So this one on the left, you can see has lots of H pluses, and the one on the right's only got a few H pluses. And once again, for this one, all of the answers are just at the top there. So if you guys could just do pages 28 and 29 today, I will see you tomorrow. Any questions about that, send me a message. All right, see you later. Thank you.